So today's notes are on identifying, naming, and measuring angles. By the end, you should be able to create angles and name them and measure them, okay? So an angle consists of two different rays with the same endpoint. So what do I mean by that? So I create a ray here, and I create a ray here. And if we name this, we'll name this A, B, C. Notice we have ray A, BA here. We have ray BC there. Those two rays create an angle. The sides of an angle, the rays are called the sides of an angle. And then the vertex in an angle is the endpoint. So here our vertex would be this B right here. Okay, so it's where the two sides of the angle come together. The set of all points between the sides of the angle is the interior of the angle. So obviously here the interior is yellow. The exterior of the angle is all the points that are outside the angle. So exterior is out here. This is the blue. Okay. You cannot name an angle just by its vertex if the point is the vertex of more than one angle. So basically, if I had another angle here like this, then I cannot name that angle R because there's two angles there. Okay. So that's what that means. And then it says in this case, you must use all 3 points to name the angle, and the middle point is always the vertex. So this would be named angle SRT, and we're going to talk about that in just a second. So naming an angle. It says an angle can be named several ways: by its vertex, by points on the rays in the vertex, and by a number. So in the picture above, the angle could be named. Let's talk about all the different ways it could be named. So it could be named angle SRT, so that's us going right here like this, or we can go the opposite direction, angle TRS, right? Then we can name this angle R because there is no other angle that has that vertex, okay? Or we could name it angle 1 because that's the number that's inside the angle. So those are the 4 different ways that we could name this angle. So now I'd like you guys to look at this image, and there are 8 different ways to name the 3 angles that we see in this drawing. So go ahead and name them and then come back to me when you're done. So I'm going to start with this angle up here, ABC. So angle ABC could also be named angle BC. Sorry, I said that wrong. CBA. So CBA. Now I'm going to talk about this one right here. This angle. Wait. Let me go back. That angle up there at the top, the black angle, could also be named angle 1 because that's the number that's inside it, right? Now we're going to talk about the red angle. This one could be named CBD, or go in the opposite direction, DBC, or angle 2, okay? Then we got one left, right? Our big angle here. So this angle out here is the one we're going to talk about last, which is ABD. So this is angle ABD, and again, we can name it the opposite direction, DBA. So those are the 8 different ways we could name the 3 angles we see in this diagram. So measuring angles. In angle AOB, angle OA, ray OA and ray OB can be matched 1 to 1 with real numbers from 0 to 180. So basically, when we measure angles, they're going to be from 0 to 180. The measure of angle AOB is equal to the absolute value of the difference between the numbers from ray OA and ray OB, and we're going to talk about that more in just a minute. Acute angle is an angle that measures between 0 and 90. You guys should already know these definitions. An angle, right angle is an angle that measures 90. An obtuse angle is an angle that measures between 90 and 180. And a straight angle measures 180 degrees. Now, the way I remember this is cute, I think little, right? And obtuse, I think obese, so I think big. Okay, that's the way I keep it. Degrees is a unit of measure for determining an angle, and then a protractor is a tool we use to approximate the measure of an angle. We use protractors to find the measures of angles in degrees. Okay, so measure. So when we're measuring an angle here, all the angles can be given with a real number from 0 to 180. So we use a protractor to measure those. So here is where our A, that whole thing is that we were talking about a second ago. So right here, notice this is a straight angle. That's 180 degrees, right? We have an inside and an outside measurement. Okay, so if we go over here and we are looking at this angle right here, we're going to use the outside measurement, okay, because we came from the left. Okay, so and it says inside measurements from 0 to 180 counterclockwise starting at the right. And so if we're using the outside measures, we're starting at the left. So here we're going to say that this was 50 degrees. Now, conversely, if we talk about this angle over here, now that is going to be the inside measure. So that would be what? 130 degrees. Okay? So that's how you use a protractor. Okay? Now this is just examples of the angles we just spoke about a minute ago. So now, example 2 says measure and classify the angles. So it says angle WXV is 30 degrees. WXV is 30Y. Because again, over here, we're looking at the inside, right? So we can see that this is 30 degrees, okay? Then it says ZXV, where's Z? ZXV right here. So that would be this angle right here, ZXV. And again, because we're late, because this V is on the bottom, we're going to use the inside measure. Okay, so again, right here, you should see that this is 130, right? Okay. And then ZXW. Now the challenge with this one is we have two measures, right? So it doesn't matter whether you use the inside or the outside for this, but you are going to have to subtract them, okay? So if we're at 130 over here and 30 there, then this would be 100 degrees, right? Again, if we're at 50 and 150, we would still be at 100 degrees, okay? So no matter which way you look at it, that's the way it works. All right, let's see if you guys can do these three down here and then come back to me when you're done. Okay, I'm going to erase this so we can use this. Find the angle, measure, and classify acute, right, or obtuse and straight. So YXV, YXV, oh, so that's 180 degrees, right? 180 degrees. So this is a straight angle. Okay. Then we have ZXY. ZXY. Okay, so this time, remember, we're going to use the outer measure, right? So when we look at this one, it's 50 degrees, right? So this is an acute angle. So this is 50, and it's acute. And then our last one is YXW. YXW. Okay, so once again, we're going to use our outer measure, and this whole angle right here is 150 degrees, isn't it? So this is 150, so this one is obtuse. All right, congruent angles. Angles that have the same measure. That's what congruent angles are. And when we are looking at drawings, and this is really, really important, y'all, we're going to have these arcs on angles that are congruent. One arc means those angles are congruent. Two arcs would mean the angles that have the two arcs would be congruent, and so on. Just as in the diagram, the measure of angle ABC and the measure of angle DEF are equal. So you can write that they're congruent. This is read as angle ABC is congruent to angle DEF. Arc marks are used to show that the two angles are congruent. Okay, so then right angles theorem is that all right angles are congruent. That makes sense, right? And then here, the angle addition postulate, we're going to use this very quickly. Okay, so it says that if S is in the interior of angle PQR, then the measure of angle PQS plus the measure of SQR is equal to the measure of the whole big angle. So again, let's just talk about what we think this means. So let's just say that this was 100 degrees and this was 30 degrees. Okay, so what are we doing here? We're going to add the 100 plus the 30, and we're going to say that that big angle RQP is 130 degrees. That's all the angle addition postulate is. The two smaller angles add up to be the big angle. Okay, all right, so using the angle addition postulate, if the measure of angle XWZ, now watch the way I do this. XWZ is the whole big angle. So when I do this like this so I know that I'm talking about the whole big angle. That's 121 degrees. And then XWY X, W, Y is this part right here, right? So that's 59 degrees, right? Okay, so when we start talking about this, it says according to the angle addition postulate, so we're going to write angle addition here, postulate, the measure of angle X, W, Y, plus the measure of, and we're going to make this one black right here so you guys can see it, Y, W, Z, it equals the big blue angle, right? So that equals the whole thing, right? That's the whole thing right there, okay? X, W, Z. Now all we're going to do is substitute in values that we have, okay? So we have that the first angle was 59. Wait, I'm going to do it in red like it was. This is 59 degrees, right? And then we're going to find the black angle, aren't we? So this is Y, W, Z, right? And then the whole big angle was 121 degrees, okay? So what do? We subtract the 59 from the 121. And when we do that, we get that the black angle is 62 degrees, okay? So we're going to do another one now. This next one, we're going to draw it, okay? Now, this is really important, too, that you guys slow down and watch me here, okay? It says using the angle addition postulate. It says K is in the interior. That means inside, right? Of angle LMN. So I always draw this angle first, okay? So you guys can use your straight edges to do this, and I would suggest you do so. And it doesn't matter what this angle really looks like because we're using it just to represent what we know, okay? And that doesn't mean it has to be accurate. So this is going to be angle L, M, and N. And listen, this M is our vertex. See it right there? So that should always be our vertex, the middle letter, okay? And then it says K is in the interior. So we're going to draw a point K right here, but then we're going to draw a ray to it, okay? Now again, this is just a representation, so it doesn't matter how accurate our drawing is. So then it tells us that LMK is 55 degrees, okay? And KMN is 25 degrees, okay? So it says, be sure to use accurate unit of measure. What postulates used when we solved this problem? Obviously, the angle addition postulate. So we're going to write that. Okay. And then it says, find the angle of LMN. So it's asking us to find LMN. So what are we going to do? So if we're trying to find the measure of angle LMN, aren't we going to add together the two angles we have? So that's going to be equal to 55 plus our 25, right? So that's going to be equal to, that's 7 and 10, so that's 80, right? 80 degrees, okay? Does that make sense, everybody? So the biggest challenge with these is drawing them, okay? Now, you're checking out, you have one that's drawn, and then you have one that you're going to have to draw. So go ahead and do both these problems, and then come back to me when you're done. So this next one, again, DEG is the whole angle. So I like to put that out here because it shows me that that's the whole thing. Then it says DEF is right there. That's 48 degrees. And it's asking us to find the measure of FEG. Ooh, I didn't mean to do that. That was there. FEG, right there. FEG, okay? So hopefully you can see that when we add these two angles that are next to each other together, they should equal the big angle. So I'm going to write it down here. So we're going to say the measure, actually let me do it in red since it was red. Maybe if I can get my thing to work. The measure of angle DEF plus the measure of angle FEG is going to be equal to the measure of our whole big angle, the measure of angle DEG, right? So again, we're just subbing in values here. So this is going to be 48. My pen is not wanting to cooperate today. 48 plus, and we're going to leave this here because we're going to solve for this one, the measure of FEG. And that's going to be equal to our 115, right? So what do we do here? We subtract the 48 from both sides. So the measure of angle FEG is going to be 67 degrees. Now here's the way you can check it. Put that 67 back in there, and is 48 plus 67 115? Indeed it is. And so I like problems like this because I can check them. Okay? All right, so let's look at this other one. Now this one we got to draw. It says D is in the interior of angle ABC. So if it says angle ABC, we're going to draw that first. We're always going to draw our angle first. Okay? With our two sides, and then this is A. Remember, B is our vertex, and then we got C, and then it says that D is in the interior somewhere. We don't really know where. It doesn't really matter where. Okay, so we're just going to draw this. Again, this drawing is just for reference. So it says DBA. So we got DBA here is 23 degrees. And then it says CBD right there is 19 degrees. So what are we going to do here to find the big angle? The whole thing, yeah. We're just going to add those two together, aren't we? So it's going to be 23 plus 19, and that is equal to, what is that? That's 2, so that's 42 degrees. 42 degrees, yeah. Okay? All right, so angle bisector. A ray that divides an angle into two congruent or equal angles. Okay, so if I told y'all this whole angle right here was 80 degrees and I had an angle bisector, then it means both of these angles right here are 40 and 40. You need to really watch for these terms. So it says JK bisects angle LJM, therefore the two angles are congruent, LJK and KJM, which means that they're also, the measures are equal, right? Okay, so we're going to do this one together, and then we're going to talk about some other stuff. So it says QS bisects angle. So it's talking about this right here, bisects this whole big angle right here. Okay, so what does that tell us? That tells us this angle and this angle are congruent. Okay. And then it tells us that the whole big angle, and you guys know I've already said this, that I like to put this out here, 8y plus 12, okay? They put it on the side there, but I like to put it on the outside because it's a good visual representation that that's the measure of the whole big angle. So it says, what is the measure of SQR? So it's asking us to find this right here, okay? Okay, so it says, can you set PQS and SQR equal? Why or why not? Yes, you can. We're going to say yes right here. Why? Because of the definition of the term bisect. Okay, that's why. So we're going to use the angle addition postulate to solve this problem. So we know that we add this angle, the PQS, to the SQR, and that's going to equal the whole big angle, right? So again, we're going to write angle addition postulate here, but we're starting to work on proofs here. So angle addition postulate. So when we're dealing with proofs, y'all, we're going to do the steps on the left and the reasons on the right. Okay, so then we're going to substitute PQS for SQR. So notice what they did was they said this is 5y minus 1, 2. Why could they do that? Because the two angles are congruent, right? Okay, and then that's equal to the whole big angle. So then they just combined 5y plus 5y, that's our 10y. Negative 1 minus 1 is negative 2. Then we're starting to combine like terms, right? So they subtracted the 8y from both sides. That's how they got the 2y. And then they added the 2 to both sides. That's how they got the 14. When you divide 2 into 14, you get 7, okay? And then what we do is we just substitute that 7 back in. Okay, so 5 times 7 is 35, minus 1 is 34, right? Now we can check this question, and this is what I like about this, okay? So obviously both of these, this is 34 degrees, and this is 34 degrees. So what should the whole angle be? It should be 68, right? So let's check that with the whole thing. So 8 times, again, our 7 plus 12, that's 56. Plus 12 is equal to 64. So we could check this by making sure that whole big angle. So it says, are there other ways to do example 4? What do you guys think? Sure, you could have done 2 times this, right? 2 times the 5y minus, you could have done 2 times 5y minus 1 is equal to the 8y plus 12. It's essentially the same, right? Only you see that these two angles are the same, so I could have just started the problem that way. Great. All right, let's see if you guys can do this one. You're going to have to draw these now. Okay, so just start with A. Go ahead and draw it, and then pause the video while you're doing that. Come back to me when you're done. Okay, so here again, I'm going to draw my angle first because it says JK bisects LJM, so I'm going to do L, J, and M, okay? And then this time it says JK bisects. So I know that these two angles right here are going to be congruent, right? So then it says LJK, that's my top one, is negative 10x plus 3. And then it says KJM is negative x plus 21, okay? So yes, I know they don't look like they're congruent, but it doesn't matter because we've got those arcs on there, so that's what tells us. So what do we know about those two? They're equal, right? So if they're equal, then can't we set them equal to each other? Yes. So negative 10x plus 3 is equal to the negative x plus 21. Okay, so I'm going to add 10x to both sides. That's going to give me 9x over here. Okay, so I'm adding 10x and adding 10x, okay? And then I'm going to subtract the 21 here and subtract the 21. I don't know that it really matters how we did this one. So this is going to be 18, negative 18 actually. So x is equal to negative 2. Now don't let that trip you up because notice that we have a negative 10. So when we're looking for LJM, M is the whole big angle, right? What we're going to do is we're going to find each of these. And I'm going to find both of them because I can check my answer that way. So negative, so when I'm finding the measure of angle LJK, that's going to be negative 10 times negative 2 plus 3. That's going to be 20 plus 3, so that's 23, okay? Then I'm going to do the same thing for this one right here, this angle, okay, which is the measure of angle KJM. This one's going to be minus a minus 2 plus 21. So that's 2 plus 21, so that's also 23. So if this is 23 here, and this one up here is 23, then what is the whole angle? It is 46, right? So the measure of angle is asking us for LJM. The measure of angle LJM is going to be 23 plus 23. So that is the measure of angle LJM is equal to 46 degrees, right? Okay. So let's see if you guys can draw this next one and do it. Okay. Pause the video. Come back to me when you're done. Here we go again. Okay, so I'm going to draw this angle. SU bisects, see that term bisects, important. R, S, T, and it bisects it, so I'm going to put it straight down the middle, and this is SU, right? So I'm going to go ahead and draw these congruent symbols right now. It says RSU is 4x plus 6, and UST is 7x minus 12. So once again, what do you see? These two are equal to each other, right? So we're going to say 4x plus 6 is equal to 7x minus 12. I'm going to subtract 4x from both sides. So that's going to give me 3x over here because that's now gone. I'm going to add 12 to both sides. So that's going to give me 18. So we're going to divide both sides by 3 because it's the opposite of multiplication. So x is equal to 6. And then it's asking us to find RSU, okay? So this time it's only asking us to find one of the angles, the top angle up here, RSU, right? Okay. I'm going to find it all just for practice sake, okay? So the measure of angle RSU is going to be equal to 4 times 6, that's 24, plus 6. So that's going to be equal to 30 degrees, right? So to double check and make sure I got the right answer, I'm going to go ahead and put it down here as well, okay? So that's going to be the measure of angle UST. And that's going to be 7 times 6, that's 42, minus 12, and guess what? That's also 30 degrees. So when you can check it, do. And even though it didn't ask us for that bottom angle because we know the angles are congruent, you should find that measure just to check and make sure that you got the answer correct, okay? So now we're going to talk about adjacent angles. Adjacent angles mean that they're angles that share a side, okay? They don't have any common interior points, but they do share a side. So supplementary angles and complementary angles are adjacent angles. So supplementary angles have a sum of 180. They form this straight line right here, right? You see that, right? So if one of these angles is 130, then the other one has to be 50 because these two, when I add them up, have to equal 180, right? And they do because they form a straight line. Now this one over here is a right angle. This is complementary angles. They're two angles that have a sum of 90. So obviously I think all of y'all know that when you add 60 to 30, that equals 90. Now here's a way to remember them. If you think of supplementary 180, you can draw an S on that 8. See that? And when it's a 90-degree angle, complementary has to do with a C. Now the other way I remember this is S is further along in the alphabet than C. So I remember that S has to do with the bigger number and C has to do with the smaller number. Two ways for you guys to remember what those terms mean. So here's our last example of the day. So this one says find the value of X and Y and the measures of the angle. What angle relationships are used to solve the problem? Okay, so I'm going to answer this question first. These have to do with supplementary angles, right? Supplementary angles. Why do I know that? Because y'all see this straight line right here? So I can use that straight line on the top to solve for X, right? Okay, and then I can use that also to solve for Y, and I'm going to show you how. So what we're going to do here is we're going to do 2x plus 4x plus 30, and that's going to equal 180 because that's the measure of a straight line. 2x plus 4x is 6x plus 30. That equals 180. We're going to subtract that 30 from both sides. So 6x equals 150, and then we're going to divide everything by 6. And when we do that, we get that x equals 25. Okay, now to solve for this y angle down here, we're now going to use this relationship. You see right there, those two actually form a straight angle as well, these two angles, right? So I'm going to find out what 2 times 25 is, and 2 times 25 is 50, right? So that angle up there is 50. So when we're trying to find the y angle, everybody listen to me, we're going to do 50 plus 6y minus 8 equals 180 now, right? So we had to find that angle up there at the top first, okay? And we're going to talk about this angle up here too because it told us to find it, but I'm going to actually finish this first. So then 50 minus 8 is 42, so this is 6y plus 42 equals 180. We're going to subtract that 42 from both sides, so 6y is equal to 138. And then when I divide both sides by 6, y is equal to 23. Now, to find these angles, we're going to plug those values back in. So 4 times 23 plus 30, this angle up here, right here, guys, is 130 degrees. And it should be, right? Because 50 plus 130 is 180, okay? And then notice we're now going to plug in 6 times 23 and subtract 8 from that. And so this angle down here, this angle right here is going to be 130 degrees. And then we can find the angle over here on this side by doing what again? Doing 180 minus 130. And so this one is also 50 degrees, okay? All right, so now the next one says find the value of x of each of the angles. What angle relationships are used to solve the problem? Here again, this has to do with complementary angles, right? So this is complementary angles. That means they add up to be 90 degrees, right? Okay, so complementary. So if this over here is 90, doesn't that mean this has to be 90 because 90 plus 90 is 180? All All right, so we're going to do this one. So we're going to say 5x plus 5 plus 7x minus 11 equals 90 this time. Combine our like terms, so that's going to give us 12x, and 5 minus 11 is minus 6 equals 90. Add the 6 to both sides to get rid of that negative 6. That's going to be 12x equals 96. So x equals 8. Okay? Then we're going to do up here our 5 times 8, that's 40, plus 5. So that means that angle is 45 degrees right here, this one, right? And y'all, if that's 45, what is 90 minus 45? Another 45, right? So let's check and make sure that it is, okay? So to find this one, we're going to do 7 times 8, which is 56, minus 11, which is again 45 degrees, okay? All right, down here at the bottom, it's talking about theorems. So it says if two angles are supplementary to the same angle or two congruent angles, then the two angles are congruent. So basically, if 1 and 2 are supplementary and 2 and 3 are supplementary, then that means 1 has to equal 3, right? Because notice this one that's repeated right here, okay? So if 1 is supplementary to 2 and 2 is supplementary to 3, then 1 has to be supplementary to 3. Same thing with congruence, okay? So when we're talking about complements, so if 1 is and 2 are complementary, that means they add up to be 90, and 2 and 3 add up to be 90, then again, see what's repeated here? So we can put the two other ones together. So whatever number's repeated drops out, and this is kind of what I like to talk about in class about triangle 1 being congruent with triangle 2, and triangle 2 being congruent with triangle 3. So triangle 1 and 3 would be congruent, okay?